So let's continue with the discussion on um, the hydraulic conductivity in stratified layers of soil. So last time, no, during our meeting, no, online meeting, we discussed on the permeability of soil, and we also solved some examples. So this time we'll continue until this kani siya nga topic is mahuman, no, as coverage as part, no, of your midterm examination. So yes, hydraulic conductivity of a disturbed sample may be different from that of the undisturbed sample, even though the void ratio is the same. This may be due to a change in the structure or due to the stratification of the undisturbed soil, or a combination of both of these factors. Two fine-grained soils at the same void ratio, one dispersed and other flocculated, will exhibit different permeabilities. The average permeability of stratified soil can be computed if the permeabilities of each layer are determined in the laboratory. So we have this sample, we have the disturbed and undisturbed samples. Meaning disturbed is that it has already undergone um, compaction and like drying and kanang pulverizing the particle, while undisturbed sample is that flocculated pa gyud ang iyahang particle, no, meaning wala pa gyud siya na compact or nahilabtan. So we have actually kana siya, they have different permeability. So we will determine now the average permeability of soil, of the stratified soil, so meaning layered soil, no, if the flow of the water is parallel or perpendicular. So we have this parallel flow of water, no, in the soil. So head are the same for each layer. So these are um the how to say, the principles if the soil is layered and the flow is parallel. So wrong spelling ni siya. Parallel flow. So head are the same for each layer because no vertical flow. All layer has the same hydraulic gradient, no, or that is I is equal to delta H over L in each layer, and different K, this is permeability, and different Q. This is discharge per unit time, no? Then equivalent permeability will be very close to largest permeability. So the layered soil is this figure. So we have this stratified soil, this layer 1, 2, and 3. And of course, they have different height and different permeability, no, because different soil man siya. So we have K1, K2, and K3. These are the permeabilities, no, of each soil. So from here, to derive this average permeability for this stratified soil, so from here we have Q. This is the basic concept. Q is equal to KIA. That is Q1 plus Q2 and plus Q3, because this one has different Q, no, discharge per unit time. So Q is K1 I1 A1 plus K2 I2 A2 plus K3 I3 A3, no? And since the hydraulic gradient for this parallel flow is the same, no? in each layer. So that is why the I is just equal to I1, equal to I2, and equal to I3. Because nganong pareha man sila, if you put piezometric kuan diri kanang piezometric tube, no? Kung magbutang kag piezometric diri, and also diri pareha ra na siya og level sa kuan. Sorry kay kahiwi, pero pareha ra na siya, no? Say na diri ah I mean delta H to sorry that is like they have the same delta, and also this is the L, no? They have the same L, so this is delta H. They have the same hydraulic gradient because of this delta H and also the same L. So that is why munang I is equal to I1 is equal to I2 and I3, you know. And we have the area, actually the area of the flow, since ang flow is from kani siya, no? Kaning horizontal ang flow. So meaning the area is the total of this H1 plus H2 plus H3 times the distance perpendicular to the screen, or kung imo ni siyang this is actually 2D man siya, bali ang atong view ani is just side view. So actually na pa ni siya ay 1 meter, or we say 1 meter, no? Nga area ana kana siya. So into the screen there is just we put 1, no? 1 meter width, so that this is the area kani siyang pinaagian sa tubig. So that is why A is equal to H1 plus H2 plus H3 times 1, no? And that A1, this is A1 is equal to H1 times 1, H2, A2 is H2 times 1, and A3 is H3 times 1. So that the Q, no, is equal to K yes, the total Q, no, discharge per unit time is equal to K1H1 plus K2H2 plus K3H3, no? And or equal to the average K in parallel flow times the total area, which is actually this is uh, this is A, napakay 1 diha, times I actually, but napud kay I diri, since naman kay I both sides mo nang gi-cancel out rani mo siya, so that this K is equal to, if you divide this one by H1 plus H2 plus H3 and also the other side, this will be the result, or K, the average K is equal to this, is equal to this equation. Hello, Ma'am Kat.